Everyone. Thank you so much for being with us here today. Before we begin, I will note that today's session is being recorded and may be posted or shared at a later time. Welcome to part 2 in the Explore Entrepreneurship Idea to Product series. Last week in part 1, John from Edge and Daniel from the Brampton Entrepreneur Center discussed some misconceptions about entrepreneurship and introduced the steps to start off with when you embark on your prototyping journey. Today, in part 2, we will be exploring rapid prototyping with 3D printing. But before we begin, I just would like to acknowledge that we are gathering here today on the traditional territory of the Mississaugas of the Credit First Nation, and before them, the traditional territory of the Haudenosaunee, Huron, and Wendat. We also acknowledge the many First Nations, Métis, Inuit, and other global Indigenous people that now call Brampton their home. We are honored to work, live, and enjoy this land. So, myself, my name is Erin Walker. I'm the Makerspace and Digital Literacy Librarian at Brampton Library. I love digital making and tinkering with technology, and it's my great privilege and pleasure that I get to do that as part of my job at Brampton Library. I'm also the library's resident 3D printer whisperer, which is a badge I've earned after many years of tinkering and troubleshooting the various types of 3D printers. And our staff like to joke that whenever they call me down to help out with the 3D printer problem, I just need to look at it and suddenly it's magically working again. So let's look at our agenda for today. We're going to talk about what a prototype is and then focus more specifically on rapid prototyping. We'll then talk about why 3D printing is ideal for rapid prototyping and then how 3D printing works and what you need to get started. We'll end off with some information about how you can access 3D printing at Brampton Library. And then of course, we'll have some time for Q&A at the end. So we are using Zoom today. So just a reminder to please keep yourself muted.
Are you off for a bit?
Keep yourself muted when you're not speaking. We invite you to turn your webcam on if you would like to and you're comfortable doing so, but it's definitely not mandatory. So we do enjoy seeing your faces. You can type any questions you have in the chat and we'll put those at the end of today's session. And of course, today's session is being recorded. All right, let's get started. So in last week's presentation, Dan briefly touched on the topic of prototypes. So I'd like to expand a little bit on that now. In the product development process, one of the key steps is creating a sample of your product before you have it actually manufactured. So a prototype is basically like a rough draft. It's a sample or a mock-up that you build to test your concept or your product. The initial creation of your product might show the basics of what your product will look like, what it will do, how it will operate, but typically a first prototype won't have the full functionality of a final professionally manufactured product. So a good prototype is a representation of your product, but not the actual example of the product itself. And I really like this example on the screen from Dyson. So you can see how they've used rudimentary materials to create the basic idea, but it doesn't necessarily resemble the final vacuum on the end. So why would we want to prototype something? A prototype is what brings your idea to life, and having that physical model is a very effective way to communicate ideas along the development process. So that physical prototype is literally going to give you something tangible that you can hold with your hands, and it's what allows you to get that real user feedback. So a physical prototype will help you describe your product more effectively with your team, your potential business partners, your investors, your attorney, or any other stakeholders who may be involved. A prototype, most importantly, is what enables you to test and refine the functionality of your idea. You might have a brilliant idea, but does it match the expectations of your potential users or customers? Your idea might work perfectly in theory, but it's not until you start physically creating and testing it that you'll encounter flaws in your thinking. So a common adage when it comes to prototyping is prototype early and prototype often. This is where the rapid prototyping comes in. So as the name suggests, it's the fast and low-cost fabrication of a physical part or model using 3D computer-aided design, or CAD. Prototype designs are usually created using additive manufacturing, most commonly 3D printing, but there are many other applications that could be used. For today, though, we're going to focus just on 3D printing. Rapid prototyping follows a simple feedback loop of design, 3D print, test or assess, revise, repeat. So you may find yourself going around in circles, just like this, as you iterate and improve on your design. So why would you want to use 3D printing for rapid prototyping? The primary advantages are simply that it's fast and it's inexpensive. You can make a low to medium performance model at a low cost and execute quick and frequent revisions. So making tweaks to your design and reprinting it multiple times doesn't cost a large cost and has a relatively quick turnaround time. And this ability to make and test small changes quickly helps you arrive at your final product faster. Also, when it comes to 3D printing, your material cost is quite low. This lets you try out new ideas and iterations with low risk and low investment. So a spool of 1 kilogram of filaments is going to run you about $25 to $50, and you're able to get multiple prints out of that spool. So this is quite low, and it really mitigates the risk of producing an expensive but suboptimally designed product with another manufacturing method. When we're talking about early prototypes, it's important to note that an early prototype should be low fidelity and gradually become high fidelity as you iterate. And fidelity is a term that's used in reference to both physical prototypes as well as digital prototypes like an app or a website. It really just refers to how true your prototype represents your final product. So 3D printing is great for prototypes on the low to medium end of the fidelity scale, but as you iterate, you may find you need to transition to a different or more sophisticated manufacturing method. And in next week's session with Candid, we'll be talking a little bit about some of the more sophisticated equipment that can be accessed in the Candid lab. So what is 3D printing? Let me know in the chat, has anyone 3D printed before? See a few responses. All right, so 3D printing is the process of building a physical object layer by layer from a digital 3D model. It's not a new concept. 3D printing has been used in the industry for decades, but developments in the technology and materials have made 3D printers more accessible and consumer friendly in the last 5 to 7 years. And this is why you'll now see 3D printers available in public spaces like libraries, community centers, schools, and even community makerspaces. Now, there's a wide range of 3D printers available, and the most common consumer level, like the ones we have in our Brampton Library makerspaces, use a type of 3D printing called fused deposition modeling, or FDM, also sometimes referred to as fused filament fabrication. So these are FDM or FFF style printers. So what does this mean? I like to describe 3D printing with an FDM style printer as like a hot glue gun with surgical precision. A spool of plastic filament gets fed through the motor and pushed through a heated extrusion nozzle. And that melted hot plastic comes out of the nozzle in a liquid form, fusing to the layer below it. And it then sets into a solid shape as it cools and hardens. And those layers are slowly built up until an object is formed. So as I mentioned, at Brampton Library, we have FDM style 3D printers. We have 2 models of 3D printers in use. But it is important to note that depending on the characteristics of your design or your product, an FDM style 3D printer might not be suitable. So designs that are very large, designs that have complex internal structures, or a lot of overhangs and angles that need support, they might not output optimally on this type of 3D printer. And I have a couple of examples. So this is actually a prototype from a local entrepreneur that has 3D printed. As you can see, this is probably not to print very well on an FDM style 3D printer. There's lots of overhangs and angles. There's very little surface area, contact with the bed. Everything is curved. It's doable, but you need to manage your expectations in terms of what the result will be. When we slice this, and I'll talk about slicing software in a minute, this is what we get. So you can see there's an awful lot of support that's going to need to hold up all those little protruding spikes, as well as the whole support spine of the object as well. So it's not necessarily unprintable, but there's going to be an awful lot of post-processing that needs to be done, and the final result might not be optimal. I do have some examples of pieces from this actual print. In this case, we did separate all of the parts and print them separately, individually, to give a better results. But you can see, because everything is curved, you probably can't see the detail, but the surface area is quite rough and not perfect. Another example, this is an industrial design student's design of an ergonomic bottle opener. And this one printed really well. It's a simple shape. It has a nice surface area with the bed, and it printed exactly as we would have expected and wanted it to. So keep in mind about the characteristics. Think of the characteristics of your design when you're considering 3D printing your prototype, and consider if it's going to be appropriate. There are other types of 3D printers, which I fortunately haven't had the chance to work with, but there are resin style 3D printers, there are laser 3D printers, and other manufacturing options out there for you. So let's talk about how we actually send a 3D print. We can break it down into 3 steps with a 4th optional step. The first is to obtain your 3D file, which is typically going to be your STL file. You're then going to prepare your file for printing using a slicing software. And then once that's ready to go, that is when you actually execute the job on the 3D printer. So let's look at each of these a bit more closely. So the first thing you're going to need is a digital 3D model. And STL is the most common file format that we use with 3D printing. It's short for stereolithography. Essentially, an STL file format describes only the geometry or the shape of a 3-dimensional object. This file format doesn't account for any other attributes like color. You may also see OBJ files used, probably second most commonly. They're similar to STLs in that they express that geometry of an object, but they can also include other attributes such as color or texture. At Brampton Library, we only have single extruder 3D printers, and these can only print in one material or one color at a time. So we find the standard STL format works best. However, STL and OBJs are both neutral formats, so this means they're compatible with many different types of 3D modeling and slicing softwares. If you know you're going to be working with a single extruder 3D printer, though, sticking with the STL format is a best bet. Okay, let's talk about the software. How do we get a 3D model? This is where our CAD software comes in. CAD basically creates a virtual blueprint of the object that you want to 3D print. And there are many, many different CAD applications available out there, ranging from programs that are little more than a digital drawing board on a computer screen to complex 3D modeling solutions that can include virtual simulations. There's quite a wide range there. This is important though, because creating a 3D CAD model for your product can be a huge task depending on its complexity. If we think back to those two examples I gave, one was definitely far more complex than the other. And the software you use to create your 3D model might depend on what your product is, if you yourself have the skills to create that 3D model yourself, and access to the appropriate software, or if you're going to be hiring this out to, say, a freelance CAD designer or a prototyping service bureau. Unfortunately, at Branton Library, we're not able to create your digital model for you. So this is something that you're going to need to source on your own. But we're certainly happy to refer you to various resources that are available and help you find the right place for you. And then most, if not all, CAD design applications and software can export to those STL or OBJ formats that we just discussed. So if you want to try it yourself for absolute beginners, we recommend TinkerCAD. This is a free browser-based 3D modeling application. TinkerCAD uses different shaped blocks called primitives, which can be stretched, rotated, scaled, grouped, carved, in all different kinds of ways to create more complex shapes. Now, there's definitely limitations to TinkerCAD, but it is a suitable environment to get started in. And with a little bit of practice, you can definitely create some pretty decent low fidelity prototypes with it. If you find you need something a bit more sophisticated, the next level up I would consider would be Fusion 360. Not only is this software very user-friendly, it also has free licenses for educators, students, and entrepreneurs. TinkerCAD also has a neat feature called Send to Fusion 360, which lets you take a design you've started in TinkerCAD into Fusion 360, where you can refine it by accessing more advanced tools and options. So you can round and bevel edges, hollow shapes, smooth out shapes, etc. You may find that you need something a lot more sophisticated, however. And like I mentioned, there are lots of other options out there. The list on the right are some free or low-cost open source options. But if you prefer a more mainstream CAD package, Autodesk, SolidWorks, and Onshape all have free or low-cost options for entrepreneurs, small businesses, and startups. So definitely do your research and see if you want to try modeling it on your own. You have the confidence to do so if you can access some of those perks that the mainstream CAD software developers offer. So if you're going to hire out the design aspect, whether that's working with a freelance designer or a prototyping service, you'll want to make sure to ask for the right type of file. You want to make sure you're asking for a file that is 3D printable. This is very important. So always ask for that STL or that OBJ or a step file, or better yet, ask for that in addition to the native CAD file. This will let you make revisions later on if necessary. So often in the makerspace, we have people coming in who have hired someone out to design a 3D model for them, and then it's been provided to them in the form of a 3D rendering that's saved as a PDF. So occasionally someone arrives with a PDF of a 3D model with the expectation that we can somehow extract that rendering from the PDF and make it into a 3D printable file. But most of the time, this isn't the case. So we can't 3D print what is essentially an image, a picture of a 3D model, but that rendering was more than likely created with a CAD software, which means it could have been exported into a 3D printable format. So keeping in mind that when you are prototyping, you're likely going to be making multiple tweaks and changes and revisions. Having access to that native CAD file is important and will make your life so much easier if you need to keep going back and making changes. All right, so we've got our STL file, we've got our design ready to start printing. The next step is we need to bring that into our slicing software. And this is actually what prepares your file for your 3D printer. It's going to create something called G-code. This is essentially instructing the 3D printer how to build each layer of your model, at what speed to print, what layer thickness or the resolution. Do we need to enable support? Do we need to enable any special bed adhesion settings. Your slicing software is also going to calculate the amount of material that will be used, as well as estimate how long the job will take to print. So your slicer settings are always going to depend on your particular model and design and the material that you're using. So there's no one setting fits all perfect setting. I could do a whole 2 hours just on 3D printer slicing settings, which we obviously don't have time for today, but it's something that we at Brampton Library can also walk you through should you come and 3D print with us. So if you're ready to 3D print, there's a few tips that I always highlight because it will save you a lot of aggravation in the long run. If your slicer setting has a layer animation or a preview setting, always run that before you save your file and send it to the printer. This is going to help you identify any problems, such as if your model isn't actually situated on the print bed. Maybe it was actually floating a little bit above it, and you couldn't see that from the initial preview. Always check your print bed adhesion settings and does your model need support. So if you have any overhangs or angles that require some extra material to build upon, you want to make sure that's enabled. Once you're confident that your settings are correct, at that point you're going to save to your USB or your SD card, or if your printer's tethered to your computer, send it to print. All right, so our fourth step is somewhat optional, and this is called post-processing. This refers to any process or task that you perform on a 3D printed part to further enhance the object. And this is going to include things like removing a raft or a support material, like I mentioned. This refers to gluing parts together, sanding, polishing. Some may want to apply a bonder or a filler and then prime or paint it. These are finishing touches which are completely optional, but which you may want to consider if the aesthetic of your prototype is important. Okay, so let's talk a little bit about 3D printing at Brampton Library. 3D printing is something we've offered at Brampton Library for several years now. We currently have 3 makerspaces in our libraries located at Chinguacousy, Four Corners, and Springdale branches. Now, pre-COVID, our makerspaces were available on a first-come, first-served basis during library hours. And we had recently, just before we closed, approved an increase of daily print time limit to 4 hours or longer by appointment. Excuse me. But unfortunately, our makerspaces do remain closed due to COVID-19. However, we have launched a remote makerspace on-demand service, which you can access from the Brampton Library website. There's a request form, which you can upload an STL file or even just a description of your project if you just want to consult with someone about your 3D printing job first. And then someone will contact you to arrange a virtual consultation. So we'll meet over Google Meet or WebEx or whatever you're comfortable with. And we'll go through all of slicer settings together. We'll make sure that we understand the dimensions, the quality that it needs to be. All of that stuff we will go through with you. And we do have a 6-hour daily print limit for this service. And we can even go a little longer on occasion. And pickup is now available from Four Corners, Chinguacousy, and Springdale branches. And of course, there's no charge for this service. You just need to have a Brampton Library membership. All right. So I'd like to open up the floor for questions. If you'd like to come off camera, that's cool, or type it in the chat. I'm just going to see if I could get one of my colleagues to read any questions in the chat out, because I cannot see the chat window.
Erin?
Yeah.
I actually, oh, Simi just got back to me. Sorry, Simi. I was just asking if we would get a copy of the slides.
We can arrange for that for sure.
Thank you.
Erin, just a quick question. So if I had a print that was over 4 hours or 6 hour limit, can I continue the print the next day?
Um, it's a little bit hard to pause and then continue a print. It doesn't often result in a good result. There are a few options. So something we have done on occasion is slice a print into multiple parts and that are then glued together. So that's definitely an option. Sometimes depending on what it is, if it's something that doesn't lend itself well to being cut into multiple pieces, we can sometimes make an exception and sort of combine it as a longer print, counting as two separate jobs. So we're flexible. We're happy to work with people who are trying to print prototypes in our makerspaces. We know it's not always easy to get your print time down to that limit, but yeah, we'll work with you.
Perfect. And what's the resolution of the printers at our libraries?
So that's the setting that we can manually set. So a run-of-the-mill on our Ultimaker 3D printer is, I believe it's 0.15 millimeters. That's kind of our normal setting, default setting, but it could be larger or smaller depending on your needs. So if you want a faster print, you could have a larger print resolution, but you'll have a rougher result. If you want a very smooth print that looks very nice, you could have a smaller resolution, but your print time is going to increase quite a lot.
Thank you.
Erin, for entrepreneurs who are working on, say, service type businesses or software type businesses, have you seen cases where these types of entrepreneurs still benefit from 3D printing? What did it come to you to print?
Sorry, for software, I can't say that I can think of any examples where someone working on software has utilized 3D printing. Yeah, I can't think of anything really.
Yeah, I think that'd be interesting. I think, for service types, if you're modeling any type of, if you need some kind of prop to provide a service.
Yeah.
It might be a bit.
I will say I have seen 3D printing used to create sort of a frame around an existing product that was a software-based product. So it was sort of like a mini screen that was run by a Raspberry Pi, and then someone created sort of an encasement for it to make it resemble the product that he was thinking of. So that's one example that I can think of.
Awesome, thank you. We have a question in the chat here. How can 3D printing be effective for an entrepreneur?
So that's a great question. I hope we've touched on some of that in today's presentation. I would say if you're just trying to get a tangible, physical something that you can hold in your hands to help explain your idea, 3D printing is great for that. It might not look like your final product. It might be very rudimentary. It might be very simple, but it's going to help convey what you're trying to communicate with your product. At a stage when you're not really willing or able to invest a lot of time or money into it, you're just considering, is this worth pursuing? Is this worth me investing my time and money into? That's what 3D printing is really great for at that very early prototyping stage.
And it's a very useful tool to help entrepreneurs learn from the potential customers, because it's one thing to describe your product concept. It's one thing to tell them about it and then ask them, oh, what do you think about this? How would you use it? It's all speculative. If you print something that's tangible, despite not having the full functionality, it creates another dimension for them to interact with and to really understand, hey, you know what? I thought I was going to use it in this way, but here's some kind of issue that I have, or I really like this particular aspect. I didn't think it would look like this. So you get really in-depth feedback about your idea, about your concept that you're looking to start, feedback that you otherwise wouldn't get, and you get it at very cheap, because if you don't do that kind of product testing, if you don't do that kind of customer validation, those kind of conversations, then you kind of risk putting a lot of time and money building a functional product for your potential customers actually get to interact and really pick apart what they like or don't like about your idea.
I actually have a really good example from the Brampton Entrepreneur Center. So we have a company named Asset Flow, and what they have done is very similar to what Erin talked about of the Raspberry kit, and then they encased it into a case using the library's 3D printing. Now, when they did take it to the client, one interesting thing is the client's like, hey, you know what, that shape doesn't work. You forgot to put ties to it so it can attach to the equipment. So instead of actually hiring a company and actually doing blow molding for it, it was a lot cheaper for them because they were able to add the actual features for the client relatively quickly. And then once they finalized on the actual product of how the product was going to hold on the forklift, then they started to mass produce the actual equipment from somewhere else other than 3D printing.
Yeah.
So utilizing 3D printing really brings down your costs and makes it a lot flexible for an entrepreneur, because you can make changes relatively quickly and you just reprint it again or add it to that particular print. So this is a great way to really move quickly, because entrepreneurship is about moving quickly and pivoting the idea as based on your customer's demand.
Exactly. Right. If there aren't any more questions, I did just want to mention that, of course, we are Brampton Library, and we have lots of resources for learning about anything that you want to learn about, including 3D printing and 3D modeling. Lynda.com is a product we have available for free through our website that you can access with your Brampton Library membership. And it has some great resources, great modules related to 3D printing, advanced manufacturing, rapid prototyping, and everything we've been discussing today. So if you're interested in learning some more in-depth information, this is a great resource. The module on 3D printing and modeling household parts is, I find, super helpful, especially if you have an idea that is sort of building upon a product that already exists or an item that already exists. That's going to be really helpful for you. So definitely check that out. And of course, I'm available. If you have any further questions, feel free to reach out. You can reach out to me at my email or our generic makerspace@bramptonlibrary.ca email account. And if you even just want to have a 3D printing consultation, feel free to submit a request through our Makerspace On Demand form, and I'll be happy to reach out. And then, of course, please join us for session 3 next week with Sheridan Center for Advanced Manufacturing and Design Technology. And they'll be discussing advanced manufacturing and accessing services. So like I mentioned, some of those more sophisticated tools that you may need to access once you've come as far as you can with a 3D print.
Erin, can I show an example?
Yeah, sure, Peter.
Okay, so guys, you may not, this is a soda stream. So this is one of these things that add CO2 to water, and they're expensive. They're bottles, that you have to use, proprietary bottles, and they're proprietary threading here. And what people have done, there's a website called Thingiverse where you can get all sorts of things that people have made. So somebody made an adapter that lets you use a standard PET bottle and fill it up with your soda stream. So, so this is something I've printed. So you thread it onto the bottle, or actually a key mine threaded in there. And pull up here. And I'm nervous doing this on my table with my laptop, but basically trust that it works, okay?
We
So-
believe you.
Right. But Thingiverse is full of things like this that you can 3D print that make your life easier and get around. Like, this is crazy that they basically decided they want to make this proprietary thing for the soda stream so that you couldn't use a standard bottle with it. So that's just an example of something that you could 3D print. It's not a lot to 3D print. I'm sure Erin would be happy to 3D print you something like this if you have a soda stream and you wanted to make your own, because it's small and it's easy to print out. So it's a way to get started. You don't have to come up with your own design. You can use an existing design.
And I'm sure there were various iterations of that design before it was shipped. So very.
Oh yeah.
Yeah, it's funny that you brought that up, Peter. Only a few days ago, our soda bottle cracked when we dropped it, and we were looking for that was a good example of 3D printing. I would actually purchase that. You should start selling those on the Shopify website for like $12.99. I think I would purchase it.
So so maybe Erin can make a business in the library of just printing these out all day when the 3D printers are down, and then people can come and buy them from the library for, or whatever, make it friends of the library thing. You can't sell them.
Good idea.
But look, 3D printing is good for creating low fidelity prototypes. You're right that people, the first person came up with this, and then multiple people contributed to making it better and better and better. And that's kind of the goal of all the things we're trying to do here is, if you guys are teaching entrepreneurship, the idea is you want to stay close to the user and stay close to the need. So 3D printing lets you create a low fidelity prototype that you can present to your potential customer each time saying, is this good enough? Is this good enough? Is this good enough? And let them go, yeah, it could be, this part could be better or worse. And ideally, as 3D printers get better, or we adapt our techniques, maybe at some point it's so good that the customer says, okay, I don't need it any better than this. This thing you made for me on the 3D printer is good enough, and I'm happy to keep it. What can I pay you to get to have it? And then you can just think about, okay, how am I making this thing, on 3D printing, from 3D printing, I never have to change it again. Or, I improve it, but I use the locally available technique of 3D printing rather than think, okay, now I have to go overseas to some injection molding process to make the device. Maybe you can always make it 3D printed.
Yeah. Excellent.
I want to circle back to Kent, who originally asked that question about 3D printing. How can it be effective for entrepreneurs? I'm wondering, with the responses, does that answer your question? Do you have any other follow-up questions? And are you currently working on an entrepreneurial project or an idea that we can help to contextualize about how 3D printing can help you specifically?
Great.
Thanks, Ken.
Okay, awesome. Thanks, Ken.
All right. Any final questions? Okay. All right. So yeah, thank you everyone for joining us this afternoon. And we look forward to welcoming you back next week for part 3 of the series.
Awesome. Thank you everybody for being here. Thank you, Erin.
Thank you, Erin.
Enjoy the rest of your day. Bye.
Bye.
Sharon.